Hello, this is the second video on factorization. We had to factorize in the last example, example 2, we had to factorize 2b squared minus half, and here just a bit of a revision of the last one. It's now obvious that b squared minus a quarter is a difference of two squares because we took 2 as a common factor and we got b squared minus a quarter. Now b squared minus a quarter is a difference of two squares, therefore we have to follow this form. A squared minus b squared equals a minus b times a plus b. Now we know that square root of b squared is b and square root of quarter is half. Therefore we can write 2, which is a common factor. We got that before. Open brackets, b squared minus a quarter, and then we keep that 2 here and we put two pairs of brackets and we put inside between them b minus half and b plus half, following that rule over there. Now, let us try a harder one now, which is n power 4 minus n power 8. As we can see here, n power 4 is the highest common factor in this case, because you can divide n to power 4 by itself gives you 1, and n power 8 by n power 4 gives you n power 4, no remainder. Therefore, we can take n to power 4 outside as a common factor, and between two brackets we put 1 minus n to the power 4, because n to power 4 times 1 is n to the power 4, and n power 4 times n power 4 is n to power 8, so our factorization is correct. And the binomial in the grouping symbols is a difference of two squares. The reason being because 1 is a square number, is a perfect square, as we know, because if we square root 1, we get 1, no decimals, and n power 4 is a perfect square because if we square root n power 4, we get n squared. And now we can write 1 minus n to power 4 in this form, following that rule again, the rule of factorizing difference of two squares. So we will get 1 minus n squared and n plus n squared, as you can see here. However, we notice that n minus n squared is another binomial, which is difference of two squares. Therefore, we need to factorize it, and that will give me 1 minus n times 1 plus n. With regard to the last expression here, 1 plus n squared, which is a binomial, but because it's a sum of two squares, it cannot be factorized. Therefore, the final form of the original expression is now taking the following form. N to power 4 is a common factor, times, in between brackets, 1 minus n, times, between brackets, 1 plus n, times, between brackets, 1 plus n squared. Now we're going to look at example 4, which is a little bit harder. It is a trinomial, a quadratic trinomial, but it has a coefficient of x squared not equal to 1. It's actually minus 6. The common factor here is minus 1, because I can take minus 1 outside the bracket to make it easier for me to factorize the trinomial. Once I take minus 1 outside the bracket, in between the brackets I put 6x squared minus 25x plus 14, because I have to change the sign due to that minus. Now to factorize this binomial, I just need to look at 6x squared, factorize it, and add 14 and factorize it. 6x squared can be factorized into 2x times 3x, and 14 can be factorized as 7 times 2. Then I can write minus 1, open bracket, 2x minus 7, close the bracket, open bracket, 3x minus 2, close the brackets. Because 2x times 3x is 6x squared, and 7 times 2 is 14. Now, to check our work, we need to multiply the nearby terms. That's 7 times 3 minus 7 times 3, which is minus 21. And multiply the far terms, the outer terms, 2x and minus 2. And that should give me 2 times minus 2 is minus 4. I don't have to worry about the x because it is repeated in here and here. I can write it or not because I'm only checking my answers. And now when I add minus 21 to minus 4 as it is shown here, I will get minus 25, which is the middle term in the last expression, which is this one. Minus 25x is the middle term. Therefore, my work or my factorization is correct. Now, this is an exercise which can be copied by the students to try to factorize, and we are going to do it next lesson. Do some of the problems next lesson. Thank you for listening. Send me your comments, please. Thank you.